Hello again! So we're back and today we'll be learning about tectonic plates and plate boundaries. So here you will see that Earth is composed of various tectonic plates. So we are in the United States and our tectonic plate is the North American plate. The Philippines is in the Philippine plate, and then South America is in South American plate. Africa is on the African plate. So these are the major plates of the world. And see these red lines here, these jagged red lines, these are what we call as the plate boundaries. As you can see, California, which is in the western side of the United States, is along this very long boundary which is called the Pacific Ring of Fire. So this Pacific Ring of Fire that extends to the other side right there, so is the place where most earthquakes happen. Subduction happen in this area, and that is where Benioff zones are located that produce shallow earthquakes. There are a lot of active volcanoes here. 75% of active and dormant volcanoes are found along the Pacific Ring of Fire, and that is around the Pacific Ocean. Now, again, these lines are what we call the plate boundaries. And in our previous discussion, we identified those plate boundaries as either transform, divergent, and convergent. So, let's begin with the transform. With the transform, two plates slide past each other, but as they slide, they get stuck, and when they get stuck, pressure builds up, and when the rocks can no longer handle the pressure, they break, and that results to earthquake. And that is what happens with transform boundaries. Of course, San Andreas Fault is the most common one, and it is mostly strike-slip fault. The second one is divergent boundary, and that can be shown here in our demonstration. So, in the mid-ocean ridge, like right here in the middle, magma oozes out from the mantle and cools down and becomes young rocks, young igneous rocks. But as the magma rises, it pushes both sides in opposite direction, which we call as the ridge push. As the plates move farther away, the rock at the end is considered as the oldest rock, and the one that is in the mid-ocean ridge, these are considered as the youngest rocks. This seafloor spreading is the reason why the Atlantic Ocean is getting wider. And these new rocks that form, eventually it will also become cold. It will also become old when it reaches the other side of the planet, where it will be once again recycled in the subduction zone. Okay? And then we have the convergent boundary. Now, in convergent boundary, what happens is, two plates like this, they collide. And when they collide, they fold and mountains form. This is what happens in a convergent boundary. Another thing that happens in a convergent boundary is this. So, we'll use this book. Now, this is lighter, this is heavier. So, we will consider this heavier one or the denser one as the oceanic plate, and then the lighter one or the less dense one as the continental plate. So when that happens, the denser one sinks in and goes to the mantle, where it melts and recycled So, new rocks are added in the divergent boundary in the mid-ocean ridge, and old rocks are melted or recycled in the subduction zone in the convergent boundaries. So, in convergent boundaries, mountains can form, rocks can be melted and recycled, and then volcanoes can also form. But of course, they can also form in the divergent boundary. So, things to remember: strike slip or transform, spreading center divergent, and subduction zone convergent. Now, another concept about strike slip. Strike slip causes earthquakes. Look what happens here when I wiggle this. See, the ground shakes. But of course, this demonstration only shows us one of the seismic waves of earthquake, the one that moves up, the one that moves left and right, which is called the primary wave. Okay? Of course, there are other types of seismic waves. The second type of seismic wave is called the secondary wave or the S wave. That doesn't just move left and right. It moves up, down, left, right. So it's like right angle, and it's more dangerous. The third one is the most dangerous. It's called the surface wave because it rolls. Like, imagine that this is the building. The surface wave rolls and it can topple the building. Now, one thing that we have to consider about the three types of seismic waves produced by earthquakes, that the primary wave is the fastest. It can travel in solid, liquids, and gases, while the secondary wave is slower than the primary wave and it can only travel in solids, and the surface waves only travel on the surface. So these are the three types of plate boundaries. I hope you have a better idea on how to compare and differentiate the three. Thank you so much.